This is the Unit 6 test review answer key. So I'm going to go through each of these questions. They'll be very similar to what you see on the Unit 6 test when you take it for Algebra 1. So let's start off by we're again practicing all the properties that we started off with. That's how numbers 1 through 6 will be, using all those product properties and multiplication properties of exponents. And so try to remember the rules where when there's the same base written twice, you're going to add the exponents. When you see a power raised to another power, then you multiply the exponents. If you see a division or a fraction, then you subtract the exponents from top to bottom. Again, as long as the bases are the same. So that's kind of the gist of it, but let's go ahead and start here on that first one. So we see here we have a 9. So you always look with the numbers first. So we have a 9 and a -1. Those two numbers, again, you can add a little -1 there, but those two numbers need to get multiplied together first. So we are going to multiply them together. 9 times -1 would give me a -9. That's what I have to start with. Then we have the x's next. You have x to the 10th and x to the 5th. So all I'm going to do right now is just kind of rewrite everything, move next to each other. You could instead just add the exponents right away and get to the answer that way. It's up to you. For the y's, we would do y cubed and y cubed, and now we're just combining them. So remember, when we combine exponents, or again, following the rules, if the same base repeats itself, you add the exponents together. Don't multiply them, you're just adding them, keeping the -9 exactly the same. So it would be -9 x to the 15th power and y to the 6th power. This would be your final answer. Let's try another one. So number 2 here, it has everything being raised to the -3rd power. Also, you want to think back to negative exponents. Anytime I see a negative exponent, I'm going to have to move, like flip numbers, or move them to, if they're in the numerator, move it to the denominator. If it's in the denominator, move it to the numerator. So in this case here, first thing you have to do though is to raise everything to the -3rd power. When you have an exponent already there, that means you have to multiply these numbers together. So we would do 2 raised to the -3. We are not multiplying these numbers together. One is an exponent, one is a number. But for the c, we are going to do -1 times -3. We're multiplying those exponents together only. And then we're going to keep simplifying until we get to a final answer. So we have -2 cubed. That is, well, first of all, whenever you see a negative exponent, that means move it to the denominator. So it'd be like saying 2 cubed, which I could already calculate. It's going to be 8, but it would be in the denominator because of that negative. Now, before I move the c anywhere, let's see what c actually is now. C is going to be -1 times -3, which is 3. It's a positive 3. It's no longer negative, so you do not move it from the top of the fraction to the bottom because it's technically on the top here. This would just be c cubed over 8. That would be the final answer. You can't do anything else to simplify this further. All right, number 3. So we have 2 sets of parentheses, each with their own exponent. So we're going to start by making sure each one gets raised to every single number and term gets in each parentheses gets raised to that exponent. So let's start with 4. So it would be 4 to the -2, x squared to the -2. So we're just kind of raising an exponent. When you raise an exponent to another exponent, you multiply them together. Same with the y cubed, that's going to be raised to the -2. So that's everything for the first parentheses. The second parentheses, we have a -1, if you want to sneak a 1 in there. -1 is being squared, so I'll write it like that. Because anytime there's a number inside the parentheses, you're going to raise it to whatever the exponent is. And we're going to do x to the 10th raised to the second power 2. So remember, keep in mind which one, this was just a positive 2 for the exponents for the last 2 terms, but the first 3 terms were all dealing with negative exponents. But we'll simplify here in just a second and see what happens. So keep simplifying here. Now, here's where I would make a fraction bar, because if it's a negative exponent like 4 to the negative 2, I need to move that to the denominator as 4 squared. Okay, so we know 4 squared is 16. I'll change that to a 16 in the next few steps. Then let's keep going. We have x to the negative 4. For right now, let's keep everything on the top, and then we'll only move things in a second. Same with the y to the negative 6 is what I would get when I multiply those. 3 times negative 2. The negative 1 squared does nothing now. It's just going to be a times 1, which is not going to change anything. And then x to the 20 is what I would get for that. 10 times 2 is 20. All right, now what we're going to do is combine these x's. We have x to the negative 4 and x to the 20. So I want to combine both of those. Let me circle it here so you can see I'm combining this guy and this one. The y to the negative 6, I'm going to move to the denominator. So here's what I have now. 16 y to the 6th on the bottom, because again, 16, 4 squared is 16, that was on the bottom. Same with this now, it's moving to the bottom, right? And then as far as you could have moved that negative 4, but before I do it, I'm going to just combine my x's first. So there's no point in moving it and then also having to deal with combining the x's. It's better just to do it right from the beginning. So the 1 does nothing. If you want to put a 1 here as a placeholder, you can. But 20 plus a negative 4 is going to be 16. So the final answer looks like this. X to the 16th, 16, or x to the 16th divided by or over 16y to the 6th. And that's as far as you can simplify, because there's no negative exponents, there's no repeating x's or y's or any other variables that come up again. All right, and that's it for that one. Number 4 is an easy one, even though it looks like it should be complicated. Anything raised to the 0 power, since all of this is being raised to the 0 power, you don't have to show any work. You just have to know that that's 1. Okay, so anything raised to the 0 power is 1. And it always will be. You don't have to show any work for that. You just always know that anything raised to the 0 power is 1. All right, we have a few more that we're simplifying here, and then we'll move on to, we are going to just do a little bit more with exponents before we move on to polynomials after that. So number 5, we have to start with making sure the whole denominator gets raised to the 3rd power. So y cubed and z cubed. The numerator stays exactly the same, y to the 8th, z to the 9th. But now I see that I have y's on top and bottom, z's on top and bottom. So when I have a fraction like this, I have to subtract the exponents from top to bottom if the variables are the same. So since both of these are y's, I have to do 8 minus 3. So feel free to show your work if you want to, or you can go right to the answer. I'll show it this time because I haven't been showing it for all the others, but 8 minus 3 would be 5. So y to the 5th, and 9 minus 3 would be 6. So z to the 6th. That is our final answer. Can't go any further from there because there's no negative exponents, no 0 exponents, no repeating x and y's, no parentheses. That's how we know we're all done. And finally, for this last one, before we get to some comparing, it says, what do we do with this cubed here? We have to simplify everything, or raise everything to the 3rd power on the top and the bottom. So we would do b squared times 3 as an exponent, right? Whenever we have 2 exponents like this, we multiply them. The denominator needs to get raised to the 3rd power, both the 2 cubed and a cubed raised to the 3rd power. So that's what we have so far. Now it's time to simplify. So we get b to the 6th for the numerator so far, because just b and then 2 times 3. 2 to the 3rd power is 8. You can use a calculator to help you, but it's just 2 times itself, 3 times. So 2 times 2 times 2 is 8. And then a would be to the 9th power, because 3 times 3 is 9. And that is my final answer. All right, so now moving on, we're still using the same rules of exponents, but now kind of just comparing some different answers because these will make a difference in your answer, of course. The first one, number 7, to find the value of -4 squared times -4, you can put a little 1 here because there's no exponent there, but this is just using the first rule, which is what we did, at the first problem as well, where you combine how many x's you had there. Now this is saying you have a total of how many -4s, but then you're going to simplify. So -4, you're going to add the exponents, that would be 3. But if you left your answer like this, Michigan Virtual's quiz or test will actually mark it wrong because they need you to simplify it all the way. So here's where you would grab a calculator and type in -4 cubed. So in parentheses, -4. And then the exponent button is right above the division bar. So this is division, it's right above it, and then raise it to the 3rd power. And so it comes out to -64. That is what you would type out if that was a question on Michigan Virtual's quiz. Same idea on this next one for number 8. Both these numbers are -3. One has an even exponent like a 2, one has a 5. But you can, again, use your calculator to help you here. You don't have to do this without a calculator, but please make sure you use parentheses. Without parentheses, you will get one of them wrong potentially. So -3 being squared like this comes out to a +9, whereas -3 raised to the 5th power would come out to a -243. So just use your calculator, but type it exactly like you see it here on my screen because I copied it exactly like it's written. So the key thing to remember here is use parentheses in calc. Okay, here's another one. 10 to the 5th power. The shortcut without grabbing a calculator at all is to count how many zeros there are. 1, 2, 3, 4, 5. That would be 10 to the 5th power would look like this. Now, if you weren't sure, you could always grab a calculator and double check too. There should be 5 zeros after the 1. Not after the 10, but after the 1, put a total of 5 zeros. So you feel free to use the calculator or the trick with 10 to raise to any power. We saw this back the first week that we covered Unit 6, the first week of the semester. 10 to any power, that's how many zeros it would have. But then number 10 here, this is scientific notation where we're raising or kind of working with powers of this number. You basically want to take whatever number is here and imagine there's a decimal at the end of that number. And now that there's 4 being raised to the 4th power, you're going to add that many zeros. So it's just 42, 1, 2, 3, 4 zeros. And you can put a comma if you want to, but again, same thing here. You could have put a comma and this would be 100,000. This one would be 420,000, but Michigan Virtual, I believe, will say not to put commas. So just read the directions carefully on how you should leave your final answer. I always do check to make sure, you're not losing points on that, but you do want to make sure you're not purposely, writing the incorrect answer either. So it's really important to follow those directions. So here it didn't say whether we needed commas or not, so I'm not going to include them, but you could always. All right, there's one final one of exponents before we move on here. We have a squared b to the -2, and we're plugging these values for a and b in. So for a, plug a 4 in, and for b, we're going to plug a 3 in. So this would be 4 squared, and then 3 raised to the -2. I could put parentheses around both, it doesn't make a difference, but let's work with each of these. So first of all, 4 squared is 16, but 3 to the -2 is going to go to the denominator as 3 squared, which is really just 9. So my final answer here, which could be written either as 16 over 9 like this, or I could write it as a mixed fraction or as a decimal. So I'm not sure how Michigan Virtual wants the answer written. It'll just depend. It'll say it right in there. I prefer not to write this as a decimal only because you'll have to round it. So unless it says it's okay to round, you could round. But really writing this in terms of a mixed fraction would be 1 7/9. You could also do it that way. Both answers are okay, but again, depending on whether it's multiple choice or if you're writing in the answer, just follow the directions on the test. All right, if you do have questions on anything we've covered so far, just go ahead and write down or star it or circle it and then send me an email and we will work through any of these that you have some more questions on before the test, whether we do it today or the next time we meet live. And I can also meet over Zoom if needed today. All right, so finding the degree, we're moving on to polynomials, which we know that means working still with exponents, but now they may have pluses and minuses in between terms. So monomials, we talked about how that's just one single term, just like it's going to have numbers, variables, and exponents all as one term, no plus and minuses yet because it's just monomials. So when we figure out the degree of a monomial, you have to count the exponents, or just, I'm sorry, not going to say count, I'm going to say add the exponents, because you want to see what the total exponents would be for all the terms together, or for the one monomial together. So like on letter A here, we're going to do 5 plus 5. Since 5 plus 5 is 10, I'm not going to write equals, but the degree would be 10, since 5 plus 5 is 10. For the next one, there is only a 9. So it just is a 9 for the answer there. Nothing to add because there's no other exponents with any variables that have exponents on them. The last one does have a 7 and a 4. So again, ignore any numbers. We're not doing anything special with the numbers. We're just looking at exponents. And if there's more than one exponent, we add them together. So this last one would be 11. 7 plus 4 is 11. So that's it for that. Pretty simple. Just add the exponents and you're done. Let's keep going here, working with polynomials. We're going to add them, subtract them, multiply them to finish up. So on the next page here, we're going to start with adding and subtracting first, and then we have lots of different examples of multiplying as well. So for adding and subtracting, subtracting comes first on number 13 here. So the first thing you want to do there is switch all the signs of the second parentheses. Make sure you only switch the second one and not the first. So this would be a negative 10a, a positive 2a to the 5th, and a positive 14a to the 4th. So all I did was switch all of the signs. These two are already negative, so I made them positives. Then 10, I had to make a negative. And then let's rewrite the whole first parentheses down, but without any parentheses now that we're getting ready to combine like terms. So to combine like terms, feel free to use different colors if this helps. We have 2a to the 5th and 12a to the 5th. That's going to get combined. We have a negative a cubed. Oops, actually before that, there was an a to the 4th that I missed. So we have an a to the 4th here, all by itself, nothing to combine to. Same with the a cubed. There's only one a cubed there, but then we have two a terms, and so that's how we're going to kind of combine everything. Starting with the highest term, I would always recommend putting it in standard form so that you know that each of your terms are going to be completely in order from highest all the way down to the least, and that way you don't miss anything. So 12 and 2, and they're both positive here, that would be 14 a to the 5th. Now I would say, is there any fourth terms? Yep, there's just that one. So I have plus 14 a to the 4th. Okay, and then we're going to look for the a cubed term. There's just the one again, minus 10a cubed. And then we have no a squareds anywhere. And then finally, we have two more terms that were a's. We need to combine those. Negative 6a and a negative 10a would be a negative 16a. And just to make sure we accounted for everything, you can go through and check it, where there were a total of 1, 2, 3, 4, 5, 6 terms. We ended up with 4 only because we combined 2 of those and the 2 of the a to the 5ths. So final answer does look like this. 14a to the 5th plus 14a to the 4th minus 10a cubed minus 16a. And so sometimes you'll have all of the terms. Notice here we're missing an a squared term, we're missing a number if you wanted to have it fully standard form from beginning to end, but this is good enough. And so most likely, because the questions will be either multiple choice, they would probably be written this way for your answer choices. They wouldn't be all mixed up in order. All right, let's try the next one. So the next one starts with, it's just addition. So this time we're just looking for like terms. So again, it helps to have colored pens like I just used here. Let's try again. I'm going to first look out for the highest exponent, and I see x to the fifths. So I underline both of those. Then I'm going to combine my x to the fourths. I see two of those. And I see some x cubes. So those will be combined. No switching of signs. This is just addition, but now we're ready to combine some terms. So we have the x to the fifths. 5 plus 13 would be 18 x to the fifth. Then we have our x to the fourth term, which would be -1 and a +7. So that would be a +6 x to the fourth. And then finally, the x cubed term, 6 plus 6 would be 12x cubed. And that's as far as we can go. We don't have to do anything from here. Now, I know there's common terms to some of these. We will work on that in the next section or next unit, working with like common factors and things like that. For here, we are done. All right, on to number 15. So you're multiplying polynomials. Now moving on to either using FOIL or the box method. Before we do those two methods though, this one here, you would just use distributive property. This is the quickest way to do that because each of those terms are just being multiplied, or 9x squared y is just being multiplied to each of the terms in the parentheses. So distributing that. When you distribute, just be careful with exponents here. So we have 9 times no coefficient, so it's just going to be a 9 still. Now looking at how many x's I have, we have x squared, y. So I'm writing it like this for now, and then I'll simplify it. You could have written x squared, y, x squared, but I just moved it so that the x squareds are next to each other. Now for my next term, there's another 9 because we're still multiplying it times no other coefficient. But now I have an x squared, an x, because that's what was here, and then a y that was there originally, and then another y that I now have. You can either put dots if you want to, or just stick them next to each other. And again, we're going to simplify this in just a minute. Then we have 9, again, one more 9, because times there's no number. X squared has no other x's with it, but the y is there, and there's a y squared. So y squared. All right, now it's time to simplify this. And again, I'm writing all my steps down. You can go right to the final answer from the beginning if you wanted to. But this would be 9x to the fourth y, because again, x's are the same. You add your exponents, plus 9x cubed y squared. So again, you're counting how many x's and y's you have here. And finally, we have 9x squared y cubed, because we have a total of 3 y's here. If you need to put exponents on the guys that were just ones, you can absolutely do that, and then it might help as you're adding them up. So final answer looks like this: 9x to the fourth y plus 9x cubed y squared plus 9x squared y cubed. All right, on to the next one. We're using FOIL or box method here to multiply. So this first one, I'll do FOIL. We have the first terms, a times a would be a squared. Then you have your outer terms, a times -2 would be a -2a. Your inner is 3 times a, so it's a +3a. And finally, the last terms, 3 times a -2 would be a -6, which you could go right to the answer or leave it like that for now. And then I'm combining those two guys in the middle because they're common terms, they're both a's. So the final answer would be a squared plus 1a, or just an a, you don't have to write the 1 in, and then -6. This is the final answer. Okay, the next one we're going to go ahead and try box with, just so that you see one with FOIL. This was again FOIL. FOIL just stands for first, outer, inner, last, which is these little rings that I was drawing as I'm multiplying. So then for the box or FOIL, this time I'll just do the box. I'm going to have 2x plus 3 along the top here, and then 2x minus 3. It does not matter which one you put where, though. You could have switched these. So we're going to multiply now. 2 times 2 would be 4. X times x would be x squared. 2 times 3 is 6. And then just an x next to it because there's no other variable. Negative 3 times 2 is a negative 6. And then again, just an x next to it because there's no other variables. And negative 3 times 3 is a negative 9. So then you would combine at the diagonal. We're going to see that these are like terms. So you can just put a loop through those. And I notice here that I have a positive 6x. Again, you can put a little plus sign. And a negative 6x. That means they're gone. There's nothing in that middle term anymore. So the final answer here is just 4x squared minus 9. Sometimes that happens where the middle term is eliminated, but you can see here that this one, it was not eliminated. So we just have different examples that you're working with. Here's another one, and a common mistake on this is to try to square the first and the last numbers. You can't do that. So please do not say it is 49x squared plus 9. I know the answer will be sitting there and it's not correct. Okay, instead, I have to write this out twice. 7x plus 3, 7x plus 3, and then use FOIL or box method to try to multiply this together. So again, I'll just keep alternating between box and FOIL. You can choose whichever method you prefer. So I'll do FOIL this time. 7 times 7, or 7x times 7x would be 49x squared. Outer would be 7x times 3, which is 21x. Inner is also 21x because it's 3 times 7x. And finally, 3 times 3 is 9 for the last terms. Combine the middle two terms so that my final answer is 49x squared plus 42x plus 9. And I can't go any further from this point. So I used FOIL here again, just like I did here. This one was box. I'll do box on number 19 as well. And then we just have a few more to finish up here. So again, on number 19, and this keeps coming up, you have to write it out twice. Please do not just try to multiply or just try to square each term. That's not going to give you the correct answer. So instead, if I am just trying to write these out both twice, I then go to the box. 4x plus 3y, 4x plus 3y. These are the same exact two parentheses. Doesn't matter, where I would put them because they're the exact same, but it doesn't matter either way. Now I start multiplying. So 4x times 4x is 16x squared. 3y times 4x would be 12xy, and I can put a little plus sign with that. So 12xy because 4 times 3 is 12. And then we have another 4 times 3 is 12 and xy. Again, I'll sneak a little plus sign in there, but you don't have to write because it is just positive. And then 3y times 3y is 9y squared. But again, you have to combine at the diagonal, and then we'll write our final answer. So the final answer would be written 16x squared. But then for these middle terms here, they're both xy's. So the xy will stay the same, but the 12 and the 12 get added together to become 24xy. And then finally, 9y squared. That would be your final answer for number 19. Okay, just a few more here. We're almost done. This next one, it's probably easiest with FOIL. But again, you can use FOIL or box method on these. X times x would be x squared. Outer, would be x times, 4 times, or this x times the 4, or negative 4, so that would be a negative 4x. The inner is positive 4x. And finally, the last is 4 times negative 4, which is negative 16. And then if you notice here, the x's are gone. The positive and the negative cancel again, just like number 17, that's what happened here as well. So when you have like opposite signs like that with the exact same terms, that's what's going to happen. So your final answer will be x squared minus 16. All right, we are almost done here. The last two, number 21, you also have to write it out twice. There's a lot of these where you just have to kind of write it out twice and then do FOIL or box method. There's no way to avoid doing FOIL or box method here without getting the correct. If you don't do it one of those two ways, you won't get the correct answer. So again, I'll do FOIL on this one. X times x is x squared. Show it kind of here so it's easier to see. We have x times negative 6 would be a negative 6x, would be my outer. My inner would be negative 6 times x, which is also negative 6x. And finally, my last ones, negative 6 and negative 6, would be a positive 36 because two negatives make a positive. This time, I don't want to cancel these guys out because they're not opposites. I need to instead add them together. So negative 6x and a negative 6x would be a negative 12x. X squared would come straight down. This would become a negative 12x, and then 30 plus 36 would be the final answer on that one. So this is different from the last one. The middle terms disappear. This does not happen. And notice I couldn't just do x squared plus 36. That's not the final answer. I have to make sure I FOIL it or use box method. So the last one we'll finish up with box because it's a little more complicated again. It's similar to number 19. We're going to write it out twice. That's what the squared means. So 2x minus 3z and 2x minus 3z. Make yourself a table or a box and write it out twice. 2x minus 3z, 2x minus 3z, and start multiplying. 2 times 2 is 4, x squared. Then we get negative, or 2x times negative 3z would be a negative 6xz. Same thing here, again, a negative 6xz. And finally, plus 9z squared. Because you have negative 3 times negative 3, which would be positive 9, and then just the z times z is z squared. Combine at the diagonal again, so that our final answer would be 4x squared negative or minus 12xz, because you're going to have a negative 6 and a negative 6, and plus 9z squared. That is our final answer. And that's the end of this review. So if you do have any questions, again, feel free to send me an email. We can meet over Zoom if needed, even today, or we can meet later in the next 2 days. All right. Let me know if you have any questions.